So it's the pace of digital transformation across Europe's energy landscape is not equally fast or advanced. But there are a number of good examples how to implement technology into our life, our cities, to help this process. Our next speaker comes from the energy company supplying electricity and gas to more than 20 million electricity customers and 10 million gas customers. Please welcome Dr. Andreas Breuer, Vice President, New Technologies and Energy Transition of RWE Germany. RWE Germany. Very nice to meet you. Welcome.
Thanks very much.
Welcome on stage. So yeah, the clicker should be here.
Okay.
Here you are.
Thank you. If you don't mind, I walk a little bit around because I'm really nervous being
Please,
here
yes,
for the first time in WebEd Festival. Thanks very much for
Thank
the
you. Thank you for
invitation.
joining.
Well, I'm representing today the old traditional utilities business. And what I'd like to do within the next couple of minutes to give you a glimpse on how we move from an old traditional business into a digital business. And what I also like to do is give you hints and advices why we do that. Because we have lots of pressure. And this is the pressure I mean. Welcome to a beautiful landscape in Germany. This is not manipulated, this is a real picture. This is the farm of Farmer Hoffmann. And what you can see on that picture, it's really typical for rural areas in Germany. Farmer Hoffmann makes more money out of generation of electricity compared to his traditional farming business. So he has shares on the wind park. He has photovoltaics on every rooftop he can get on his farm. And also he's producing biogas, which then is used to generate electricity. And in that area, it's called Eifel in Germany, you have 8 times the generation compared to the consumption. And if we also transfer that to cities, we also see a trend of increasing electricity consumption. So what I like to do is bring you into my day-to-day business, and also very important is companies who are not existing in the traditional utility business are moving into our business. Like, for example, Google with buying Nest thermostats. We have a cooperation with them in the UK market. Or you can see companies collecting small generation units, bring it on a virtual platform, they call it virtual power plants, in order to trade the electricity and give value to the customers. A topic which I do not want to touch today into depth is smart metering. Especially in Germany, it's a real sad story because we did not even start with a smart meter rollout. But I give you some ideas on how we see smart metering in addition to what customers need. And by the way, RWE, active in 8 different European countries, is the biggest e-mobility infrastructure supplier today. So coming to the actual business we have, what we see is a huge increase of renewables in rural areas, but also in cities. What we also see is that we do not have the right infrastructure in place. It was not built for implementing or feed-in of electricity on a decentral basis. What we also figure is that the biggest problem a utility today has is the volatility of renewables. And therefore, I can give you some examples. Roughly 2/3 of the new generation plants, photovoltaics and wind, are attached to medium and low voltage infrastructure, which is the lowest voltage we have in the grid. It's not implemented in the highest level where we are more or less really smart, having all the information we need to steer and control a grid. It is attached to the low voltage and the medium voltage where we do not have the right information in place. And this is what I mean with volatility. This is a typical pattern for wind and solar generation. And what we are forced to do as a utility is we need to take out every single electron which is produced from renewables. And therefore, we do not have the right infrastructure, which means normally we have to bring in new lines and new cables. And now the bridge to digital. The question we raise is, in lots of projects I have in my department, is are there any digital solutions, are there any smart solutions instead of bringing cables into the bottom, instead of building new lines? And indeed, there are. What we see in future in the utility business is we need lots of sensors. We need lots of smart algorithms. We will be in future fully automated in the grid. We also focus on self-learning algorithms, and a lot of projects and initiatives in the utilities business started with raising the question, can big data analytics help us to be more precise in controlling the infrastructure, like weather forecasts, for example. If you are able to forecast very precise the upcoming days, you are able to precisely control your grid. So what we did is we searched for solutions, and we found one solution you can see in the back of me as a container solution. Behind that, it's purely software, hardware, and power electronics. We bought that container in New Zealand because for the first time this container, this power electronic was used in a distribution grid. Normally you will find this power electronics to have a precise quality level in very crucial or critical industry production, like fiber optics production, for example. And we implemented that from New Zealand coming into the distribution grid. We paid for that €1 million, by far too much. Therefore, we started an initiative and project which we called Smart Country, and collected several partners. Because without having partnerships and corporations, the trend or the movement towards digital will not be fulfilled in future. So time being, we found a solution for a redesign of this container, and now the market price is €250,000, 1/4 of the original price. And then it makes sense. Then we have a positive business case. And what this container, this power electronic does, and the software and the algorithms behind that, is on the left side, the blue curve is the volatility of the feed-in of photovoltaics in that area. And after feeding in that volatility of the voltage, the output voltage is the red line. The effect we gained with using this power electronics and algorithm was that we postponed the investment into new lines. This line, this quality of voltage helps us to keep the existing infrastructure instead of building new lines. And automatically you can see there's a huge positive business case for that. Also, what we focus is that we want to use market mechanisms, market processes from our customers for grid purposes. What I mean with that is we introduced a traffic light system. If traffic light is green, anybody can use our infrastructure without any restrictions. If we have some danger occurring in the next days, for example, the traffic light switches to red, and the distribution system operator directly interferes. But the funny and the interesting part is the yellow traffic light, which means we need flexibilities. Flexibilities in that case can be more generation from the customer, less generation, more consumption or less consumption from the customer. And we want to buy that. But if we want to buy that, we need to know where it is. And this directly leads to smart operator. This is the latest project we implemented. The basic idea was if we have a smart self-learning algorithm directly at the side of the customer, which directly communicates to all the different customers in a certain area, will we be capable to use these flexibilities in order to have a self-assessment in the grid and also a self-control of the grid. And this we achieve by implementing and attaching e-mobility, because the battery in the car can be flexibility potential. We implemented batteries in the grid. We are connecting to households, warm water, heating system, pool pumps, also battery storage in the households and PV installation on the rooftop. And having all these flexibilities in place, they permanently send the information to smart operator, and smart operator collects. And then, if we have a precise prognosis for the next days, smart operator talks to the different households and says, tomorrow I will need your heat pump. Tomorrow I will need your battery storage to a certain extent. I'm going to pay for that. And then the smart operator automatically decides which flexibility to take. And also this one reduces the grid extension costs by far. It's also a huge positive business case. And we implemented that in 2 areas in Germany. And we are now ahead of bringing that product on the market, because this is not a typical RWE problem. This is a typical utilities problem all over the world. Wherever you have lots of renewables, lots of volatility. I'm sorry, please.
Just one question.
Yeah.
How do you make the contractual arrangement? Is it bilateral or
Exactly.
contract, or is it part of your general terms and conditions?
Very good question. Thanks for that. It's a bilateral contract, because what we use is data from the customer. And the customer needs to say, yes, you can use my data. And therefore, it's a pity, but therefore we need a direct single contract with each and every customer. Now, assuming that we have 15 million smart meter points within RWE, we need to find a solution for the framework to do contracts, because I'm not willing to do 15 million contracts with all my customers for looking for flexibilities. So also one big effect of these kind of projects is we shift the results into the political and regulatory discussions. So one thing focusing directly and only on smart cities is cities have an increase on electricity consumption. Cities have a lack of space. Cities have very huge, big infrastructures, like 110 kV infrastructure, for example. You can think of a huge gym within the different areas of a city. And assuming that you can reduce these various gyms which bring the energy into the city to a double garage, this will be very helpful for you. I'm sorry, I clicked that. Will be very helpful for you to reduce space, increase electricity consumption. Who of you ever heard about superconductivity? Oh, that's more than I expected. That's great. So a material with a certain temperature can transport electricity without any losses. And this is the cable here. For the first time, the world's longest cable, we implemented that in the city of Essen, 1 kilometer. Minus 200 degrees centigrade of cooling, and it transports 40 megawatt of energy in a double garage, instead of using huge transformers which we can take out of the city. And we cooperate with the manufacturer and spread the information and also participate in various projects all over the world, because this will be a new possibility for supplying energy into high energy density cities. And bringing all these results of the different projects in one project in order to orchestrate all the single solutions I showed to you, we are starting now with 47 partners, the biggest R&D project ever we did, 100 million euros. And what we try to do is we want to design a manual for the energy transition. So that was my conclusion. Thanks very much for your attention. And whenever you have questions, please, you're free to ask.
Well, obviously there will be. Thank you so much for being with us. Thank you.
Thank you.